In this tutorial video, I want to show you how to find a maximum and minimum value on the graph of a function. For this example, I'm going to graph the cubic equation y equals 1/3 x cubed plus x squared minus 3x minus 10. So you can see I've hit the y equals button on my calculator and entered that equation. Y equals 1/3 in parentheses x raised to the third power plus x squared minus 3x minus 10. So if I hit zoom and graph in the standard window, you can see over here in the larger window a picture of my graph, and you can notice that in this region here there's a maximum y value or local maximum. And it looks like down here there's another turning point on the graph which looks like a minimum, local minimum y value. Now, since I can't see that y value, I'm going to go ahead and adjust my window. Remember, my minimum y value in my window is -10, so I'm going to hit window and change that y min of -10. Let's try -20 to see if that gives us a good picture here. I hit graph, and yeah, that gives us a pretty good picture. So again, I can see here's a local max. The y value here is a maximum compared to all the other y values in this region, and the y value at this point is a minimum compared to all the other y values in this region. So let's go ahead and find both the max and the min. And what I'm going to be doing is under the calc menu, which is above the trace key, I'm going to hit second trace, and in the calc menu you can see number 3 is a minimum, number 4 is a maximum. And I guess I'll just go in a left to right fashion. If I look over here at the graph, the maximum came first, the minimum came second from left to right. So let's go ahead and find this maximum first. Let me choose number 4 and hit enter. And let's find that maximum. So 3 things the calculator is going to ask me for. One is a left bound, and you can see right here it's asking me where's the left bound. Second one will be a right bound, and then a guess. So since I'm finding this maximum, I'm going to go ahead and hit my left arrow and take that blinking cursor as close to that maximum as I think I can get. So roughly around there somewhere is my maximum. So the left bound is I'm going to hit my left arrow a couple times and move to the left of the maximum. So if the maximum was, let's say, at -3, I've moved to the left on the x-axis over here. Notice I'm at about -4, and I'm going to hit enter and say there's a left bound. Notice how it puts a little arrow up here, visually telling me it's going to not look any further left than this point. It's going to look from this point on. Now it wants a right bound. So I'm going to do the same thing with that blinking cursor. I'm going to move about to where I believe the maximum is, roughly there, and I'm going to move to the right a couple places. Now, how far right should I go? Doesn't really matter. The only thing I want to be careful of is don't move it all the way to here. If I move it over here, then I'm encompassing a minimum inside the maximum range. So really doesn't matter how far you move to the right, just make sure you don't move so far that you encompass another max or min value. 4 or 5 clicks is usually good enough. And let's hit enter. There's my right bound. So you can see I'm telling the calculator that within these arrows is the maximum that I'm looking for. And it wants me to take a guess. So I'm going to move the blinking cursor, about at the maximum and say, let's guess there's the max. Quickly calculates for me and tells me that at -3 y is -1. Now, one thing I want to point out to you that the actual x value where the maximum is -3 exactly, but the calculator is doing the best that it can to find that value. This is pretty good approximation of that x value, but it's giving me the actual y value that is the maximum in that region. So the x is pretty darn close, and in fact if I hit trace and punch -3, I can see that exactly at -3 the y is -1. So it does the best it can to give me the exact x value. Sometimes it gets real close, but not exactly there. but the y value that it had given me was definitely the maximum y value in that region. So to find this minimum, I would in essence really do the same thing. I'm going to hit second trace, and in this case I'm finding a minimum, number 3. So I'm going to punch number 3 to find a minimum. I'm going to basically go through the same procedure, but now I'm going to do it with the minimum. So I'm going to move my blinking cursor about where I think the minimum is, and the first thing it's asking for is a left bound. So I'm going to move to the left, 3 or 4 clicks, and hit enter. Now it wants a right bound, so I'm going to move to the minimum, and 3 or 4 or 5 clicks to the right to give it the right bound. And then now it wants a guess. So I'm going to move the blinking cursor about where I think the minimum is and say there's my guess. It quickly calculates, and again here is where the minimum is occurring. So that's really trying to give me x equals 1, and this is the minimum y value. So -11 and 2/3 is what that is. Again, if I hit trace, punch 1, I can see that's exactly what the x value is trying to give me. So the minimum value is occurring at x equals 1, and the minimum y value actually is -11 and 2/3. And that's how you find a maximum or a minimum value of a graph.